It's time for Myth of the Week.
All right, well, this one goes back to the way back machine. This is one of our original myths from when we were first arguing it, myth number 19. And what we did was we sat down, a bunch of us Sparkies kind of sat down, and we decided like what always gets argued about in the groups. And this was one of the old ones that it probably goes back 5-6 years. But basically, what a lot of people argue is that you have to have bonding bushings with this flexible metallic conduit going into, like in this example, the transformer. Well, if this flexible metallic conduit was like less than 6 foot or less, you still couldn't use it as an equipment grounding conductor. So that's not what we're talking about here. This is basically if you need to ensure the bonding path with that flexible metallic conduit. And what you'll run into is that a lot of people think, well, you're over 250 volts to ground with that 277, but the only time when you're going to need those bonding bushings is if you have eccentric, concentric, or if you use like reducing washers or something. This case, they used them on both sides here. That's not required. So it's kind of the reason I do these myths is because it's a lot of fun to kind of get people to think about this and think, hey, in this case, you're pulling a full size equipment ground through there, so your path is already insured. But I do understand where people come from, where they say, well, what if that flex breaks? What if a meteor hits that? You're gonna lose your bonding path. So there's a lot of what ifs that come up in some of these myths, and it's a lot of fun to do them for me because I really like reading all the comments and just seeing what other people think about, well, this and that and this, and it's really cool. So, and I get James to kind of, bring out his stuff, and then I get other people out there, like David Englehart. And this is a really good point, David. The metal conduit, flexible metal conduit might need a bonding bushing per 250-97, 250-92B4, 348-60, and 250-118A5, which that's in your honest opinion, David, and I really appreciate the comment. The first part I'm going to disagree with is 250-118 because you're not using that flexible metal conduit as an equipment ground. So I just don't see why that would really be a relevant code for requiring a bonding bushing. But I'm going to let James just go to town on this one.
Well, let me start off with the what if game. Okay, because I get a little tired listening to somebody when they all say, what if this happens? What if this happens? Well, let me address that, okay? When you look at, and I'm going to use 70E as an example to start this off, because if I need to go work on this, I have to address it in an electrically safe work manner, okay?
Yes, sir.
Now, when you go over the 70E document and you go to chapter 2, you're going to pick up 200.1. Now, all through the first portion of that in chapter 1, there's a lot of relationship to where I'm going to go with this. But when you look at that, it talks about maintaining the equipment per the manufacturer's instructions are an accepted industry standard. In this case, that would be NFPA 70B, which is your electrical equipment maintenance. So if you're maintaining the equipment, there shouldn't be a what if at that point. Okay.
Well, and you also go into normal operation. Mm-hmm. So the National Electric Code is for normal operation. If you get a broken conduit, that's not a normal operation that the code's intended for.
Well, it's like you pass in front of some equipment and the equipment switching and everything. Okay. A lot of people would say, oh, you can't walk in front of that because the equipment's switching. Well, yeah, you can because that's under normal operation. I've ran into this a lot when we first started teaching 70E and we were trying to explain everything. Well, one of the next steps in the evolution that I was talking to everybody when I was teaching all these classes all over the country is that when you look at the 70 document, it wasn't being pushed as much at that time, probably about 8 years ago, 6 years ago. And I said, you need to really get ready because 70B is going to come into play. It's going to be the next biggest document at NFPA. And the reason that is because of 70E. Because when you work on equipment, the equipment has to be maintained properly. So when I hear somebody say, what if this happens? Well, I understand things can happen, but you're supposed to maintain the equipment. Now, I know that's usually the bigger facilities that will do that. You'll go into a lot of facilities that don't really maintain their equipment that are smaller, but they are actually required to do that. And if something happens, if I went in and I was going to work on something and I saw something like that, I'd say, hey, you might want to fix this because if something happens per OSHA, because OSHA recognizes it as an ANSI standard, that has to be maintained. If something happens there, you're responsible for it. I would make the owner aware of that. Okay, might pick you up some good maintenance contract. So, you know, I always try to express that first and foremost because I have heard, you know, as we've done a lot of this, you know, people say, what if, and I just wanted to address that first and foremost. All right.
Did you remember one of the myths where I had that picture of like that smashed MC cable, where it was just like getting crushed up against the wall and it was just like basically flat to the wall?
Oh yeah, that's
where my subject of physical damage. Like they didn't even want to fix it. I was like, hey, do you want me to fix that? And they're like, no, what's wrong with it? You know, so that's what's funny about the whole what if thing. Like, what if a cart slams up against that thing 4,000 times? Oh no, it'll be fine. You know, so
and that's another thing right there that I try to bring up is if I was out on the job and I pointed that out to them, I'd say, look, if something happens there, that wire's crushed in there and it comes energized, some kid touched that and they get hurt real bad or killed, you're responsible.
Yeah.
I would tell them
100%.
And
100%.
those are things that you look out for when you're out there. You know, I have this one friend, he's a contractor. He actually goes out and eats all the time. And he said he'll just look around, he'll see something electrical, he'll go up and tell them that. And he says you'd be shocked how many jobs he's done because he brings it to their attention. And he ended up picking up clients that way.
Yeah.
So, gives you an idea.
Everyone wants electrical safety in the workplace.
Sure. Now, this, as David referenced here, 250.97, and I understand exactly what David was saying. When I, you know, it's funny because when I look at the myths, when you put them up there, I'll look at the picture, I'll bring it over and look at the picture. And when I looked at the picture, I was like, oh, that's a transformer. I doubt they went over 6 foot, so I didn't even think to consider it because I've never ever seen one. They usually, you know, they pop down to it and it's right there, you know, and usually they're anywhere from 4 to 6 foot, maybe 3 foot that they'll make that connection depending on the size of the flex that they're using, of course. But David was 100% correct that when you're looking at that and you look, I know he referenced, was it 348.6 is grounding, but where because that's your wiring methods chapter for flexible metal conduit. But the one I would really look at is 250.118A5. And that's where it gets in and starts talking about the size of it. I wonder if it needs to be on guard as 250. No, because when I go over and I look at 250.118.85, A5 is where you get in at 6 foot or less, that you got the equipment ground in there. I mean, you could do it without the equipment ground. All of that is still providing. The only time you're really bonding is to provide the continuity for the equipment grounding conductor path. That's what it's really for. Okay. So
Sure.
if it's 6 foot or less, I would say no. If it's over that, I'd pull the equipment ground in, and you probably want to bond both ends at that point. Okay, that's the way I would look at it. Now, some would look at that and say, "No, I pulled the equipment ground in, but I feel you're over 6 foot." And I sort of agree with David. The section he was posting 96A, I would take and I
Okay.
would bond that in at that point. Okay, that's the way
Okay.
I sort of look at this. Now, there is an exception here, the one that you would look at, because part of that question you were asking, it was on concentric and eccentric knockouts, wasn't it?
Yes, sir.
Okay, so the exception here says if they're not encountered. Okay, so now you get to do a few different other things, but that's what you got to look at is when you've got those concentric and eccentric knockouts, and that's where you start wondering if it's going to be bonded correctly. Okay,
Sure.
and then I'm going to look at it as far as the wiring method, and if I have the equipment ground in, if all that's bonded together, and you got metal to metal at that point, and I would feel that was okay. All right, and the
Yeah,
same.
and I would actually say if you use reducing washers or whatever too, that's not a field punched hole
That's
at
correct.
that point.
That's right. And then when you look at services, I don't know if that transformer is going to a service or not, but um, this is where you get in and you start looking at this. And then when you look at one, it talks about bonding equipment and the type of methods you can use in 250.8A. So this is where they start talking about meeting the requirements here. And it says such as what? Reducing washers or oversized concentric or eccentric knockouts. Okay,
Yeah.
so they're telling you that you need bonding jumpers around those areas if they have been what? Impaired. Okay, and these are things that you want to look at as far as your different type of bonding means, and then you go look at 250.8, and then this gives you your things here that are considered when you're using them as equipment grounding conductors, grounding electroconductors, and bonding jumpers for the means of what? Connection. And just go down here and look. And then what you're looking at is making sure that all that fully seats up onto the enclosure. That way you're making metal to metal enclosure. Okay?
100%.
Or metal to metal connection, should I say, in metal to metal enclosure. But that's the way I would view this. Okay?